Okay. 2 years and a half before, I didn't have any touch with the medicine, so it was the CLASSICA project was the first one. As the talk should be how I did it, or how I do it. No, I will be very concrete, but hopefully, as you are medics, I won't go too deep in technology. As I was a developer, and I can say not AI data scientist, but let's say I'm leading the technical team in CLASSICA. First, some information about our company. We are high tech, IT, absolutely, and the largest high performance computer in our part of Europe. And currently we are engaged in numerous EU projects from now medicine, defense, and other verticals. No? And also we have some certifications, so you can see that we respect industry standards. CLASSICA, probably everyone already heard of something about it. Is EU-funded projects deploying and looking to deploy cancer classification in the operating theater. This is important, in operating theater and in real time. This is what is, so we want to recognize cancer and or distinct non-cancerous tissue before the procedures, in the procedure. No? We validate biopsy and tumor identification across diverse patients. So we have multi-site and multi-layer clinical trials, and this is important to respect also the biases that AI can bring in with data. No? And as you will see further in our partners, no? We aim to develop a new clinical guidance for the AI in the operating room, and also establish clinical, legal, and ethical procedures that to, let's say, responsibly implement the AI in the operating room. The partners are really, thank you, Ronan, again, really brilliant consortium of partners, 5 clinical sites, Italy, Austria, Belgium, Netherlands, and certainly Ireland, and others are coming. And then 2 law university, Copenhagen, and before Penn State, now Illinois College of Law, and IRCAT, which is, IRCAT from bringing knowledge to this society. No? What is important, and we really appreciate, no, is the, let's say, this kind of partners ensure really multidisciplinary, holistic view of AI in the operating room. Now, how we started CLASSICA project from the proof of concept, let's say, which already was done by UCD and IBM. And what was our aim from the beginning, no, was to be not only explainable, but possibly interpretable, which means to really understand what is happening with during our findings in the operating room. All is based on different perfusion on the tissue, no? the lesion and the normal tissue or benign. And with infusion of ICG, we follow the brightness of the tissue during 5 minutes. This is important because the clinicians don't appreciate a lot being still for 5 minutes. But I will tell more on this after. So from the beginning, we decided to use, not to involve too much bias, no? So we use striker in every site now. Striker cameras, because it's really important while cameras are also adapting the field of view with the changing of position of the camera. So we have the RGB, no? This is RGB, and near part of view, and we track the RGB, helping also with the near view, and during this 5 minutes, no? And we just collect this data, and we simply we draw the curves, and we process the curves. This is quite complex process to how to smoothening the curves, because you see the camera is not still and the patient is alive, no? And is breathing, and it's really 5 minutes. It's a lot. You will see maybe when you are during the procedure you don't see it, but when you accelerate it, you see how fast it's moving, no? And then from these curves, we try to understand the properties of these curves, so features, no? How fast is going up, where's the peak, how it's going down, and so. And then with these features and the pathology findings, so annotations, we train the AI system, no? And try to classify the lesion. To say just, we put the grid on the field of view, so we named it region of interest. For now, there are 150, and now we aim to go to 750. It's not by pixel, because it's very difficult to track pixels. And then I will, okay, after. So this is how we start, no? Now it's 2 years, really hard work. In the first half a year, we have only 4 videos and some of, let's say, pipeline, understanding of pipeline, and we learn something, no? But as said before, domain knowledge is really important. It's a lot of technology, no? But at the end, to understand something is domain knowledge. So we didn't have it, and clinical partners here are very, very important. So the first, when we see that we have a lot of work to do, we develop, let's say, test program, no? Application. It's 8 times faster, no? But you can see how we track the RGB near how the grid is going, no? And we lose something, and it's very important to understand, because while I started with the explainable or interpretable, no? There's the aim was from the beginning, as also Pietro said, it's difficult to understand where it's failing, no? The AI, no? So we say the quality, we don't know how to name it, but quality. At the end, we put quality on each of 3 phases of the AI pipeline, no? We don't have really precise thresholds yet, but as we learn in the clinical trials. But what is important is we we want to say when we are certain, because people normally, we know just 0, no, 100, or 50-50, no? People don't know what is 63%, no? They don't understand, no? So what we want to gain is that knowledge when to say we are sure that this is, that all the pipeline is going well, and we are confident in the results, not 100%. We are confident to give you information about this is important, no? But just to, and then we came, at the end, we have all the multi-label information about normal tissue, benign, or cancer. This is benign, and all the numbers, and I totally agree what Daniel said, no, about the metrics. We have to understand. It's not the metrics, because we have to understand what is happening behind, no? And as we have, what is also important, this test program, how we do it, no? And why we use also HPC, because this program really creates a lot of data, 50,000 data points, images. We detect, automatically detect inflow. We recognize instruments also. No, all what you see, because we want to understand. No? So if something is happening with the field of view, we want to know. And for the classification, we try a lot of features, no? A lot of different algorithms, no? And we implemented on the HPC. We translated to have it parallelized, no? So we run on HPC each time something changed, no? We rerun all the videos for 5 minutes, no? And all the data to compare that when we change something in any stage of pipeline, at least for each video, it's at least so good as previous algorithm, and it has to be better in performing, no? So it's also a lot of work behind, no? Well, we understood that when you come to certain result, no, gaining percentage of accuracy, sensitivity, it's very difficult, no? So you have to go. Sometimes you have to go back, no, to understand again with the clinicians. Absolutely know what is happening, no, with which video, but not only video, with each region of interest, with what is happening with the in each phase of the. So it's just a tool to see how the work is not, because as I said yesterday also, no, many things that you just bring AI in something and everything is working, no? Far from that. It's a lot of work, no? And it's not linear even, no? This is the problem. When you're developing something, it's linear, no? More code, more developed application. When you are talking AI, no, you have this breakthrough only when you find something. So it's really difficult. So now we are and we are giving this also to the let's say knowledgeable clinicians, no, and with them we try to understand what to do. Now we are starting study 2. Study 2 will go. This is some old video, no, but we are going in the operating room. We already tested in operating room. In Dublin and in Graz. just automatic inflow, make, and what we've learned from 2 times we were in the operating room, just to prepare operating room, you have to have operator, and that there's too much data. So Pietro, I totally agree. We don't need, because the clinician in this 5 minutes, which we absolutely try to reduce, no? But to our understanding, we see many videos that in the last, after 150 seconds, we see this difference between benign and cancer. So we will extrapolate, and so it's a lot of work. And this is how we will show in this study, where it's comparing biopsy. No? We show where to do the biopsy to the clinician, just then to compare what is the let's say the difference. No, so it's going inspection will go out. So this user experience is very important. No? And then all the videos are uploaded. We do develop also the platform, no? Where we store and share, and you can re-see everything you have, and also it automatically goes in our pipeline to test, no? The adding to hold out videos, not to so challenges, medical stuff. Now, I think this at some end, no, this has to go into the instrument. No? So you have camera system, no, and this should be implemented inside. And also this is quite technical. We are thinking just because all AI implemented in what you saw, the first applications were in Python, no? But when we go in the operating room, is the performance of laptops, so the model, the design, absolutely. We have also, let's say, for tracking, no? You have many possibilities and many models, no? But we have to select one who is performing well enough and also stays real time, no? Now, we have in the operating room for this study the other monitor, bringing the laptop. You have to have operator behind it, and so then the patient, no? The patient is not still. We see it's absolutely. This is the problem. The next thing is the lesion. The lesion is everywhere. You can, or it's too big for, because we need we normalize video for we need tracked region of interest with normal tissue to, because the camera is really understanding the camera was really tricky. So how is position the lesion? No, we saw also that probably we will use, based on the position of lesion, we will use different algorithms. No, to so, and we will let also now in the second phase we'll start also with the neural networks. So to compare the results. No, and a lot of unknown. No. Every second video it's coming new, it's something new. We find out something. So this is really let's say nice for developers. But okay, this is life. No, technology, as I said, camera is very important. No, and we now starting with also with other. Not only Striker, just to test, because not everybody has both RGB and near infrared. So overlaying, you have to work around to get RGB and so a lot of technology. Tracking, new algorithms is coming. For us, it's important that it stays real time and it's, let's say, good enough, no? And we understand it, that we know at the end that it's okay. Curves, we did a lot, no? With smoothing and understanding the features, and I think there we are quite important. For classification, new cases, no? Cases because as maybe radiology has for years many data, no? And images. We don't have 5 minutes still camera movies, no? So we are practically creating our data set here. But what is important, no? In the first clinical trial was observational, so we only get the video to learn, but to feed back also to clinicians, no? To clinicians to understand how to do it, no? So it's not only our part, no? When if you prepare all the procedure, no? It's our part is in the middle, no? But it's before ICG, how, and then the camera, and then comes the technology. Where we are starting the study 2. It's so we say where to do the biopsy, and then the aim is to compare the results between AI, and the biopsy. And study 3 will be to do the heat map, no? So to understand where the cancerous tissue is, with some certainly so to guide the recession. In study 2, absolutely we already do the heat map, but no clinical decisions should be done based on it, no? They know that we show the region where to do the biopsy with the highest level possibility of cancer, no? But it's shouldn't decide based on it, no? Probably in the future, no? If we go, we already try some videos with other organs. The idea is the same, but certainly we saw how detailed we have to be, and it's a lot of work also. We have the pipeline, we have everything, but produce videos and data for every organ will be the same, and then the clinical trials and everything is. And then this is the picture from Torino, from our last plenary, Alberto Arezzo lab. This is autonomous robot, future, let's say, autonomous. I agree we are far from there, but as a technician, I believe absolutely in this future will be, but probably no job here is at risk, no? Maybe in the next generation, probably yes. So what is important? Take AI, bringing in the operating room is a journey, and really it's not easy, and it's a lot of work. A lot of work, retry, successes and failures, but we have to do it because of the humanity, no? We will do something good for humanity. So this is my. Thank you very much.